Hello everyone, welcome back to yet another video on our channel Euclid Mathematics. Today we are going to learn previous year question from CSIR NET June 2018, which are 4.75 marks. That means multiple answer questions. Question is from subject of calculus of variation. Now question is here, the external of the functional j of y integral over 0 to 1 y dash square of x dx and subject to condition given y of 0 0 y of 1 1 and integral 0 to 1 y of x dx which is equal to 0, and options are given here. We have to figure it out which one of the option is correct. So let's dive directly into our solution and we see how easy that answer is. As we observe our example, we see here that we have two integral which is given as here. It is the two integral which is given in our example. So here it involves two different integral. So to dealing with such a problem in calculus of variation, we have to use concept like isoparametric problem. So isoparametric problem, it says that when we have two different integrals, so we write this integral of function f which is equal to small f plus lambda times g. Okay, so we have to write that one function as small f and another one is a g, and we have to substitute these values here and we proceed further. So we want the value for f and g. Now consider first integral as f and second one is as g, and lambda is here Lagrangian multiplier. So f it is here y dash square of x, it is f, and g is here y of x, and lambda is a Lagrangian multiplier. So substitute the value of f and g in our isoparametric type of problem. So f it is here and g is here. So capital F which is equal to f y dash square plus lambda times y of x. Now by using Euler equation we can solve it further. So Euler equation, it says that delta f by delta y minus d by dx of delta f by delta y dash which is equal to 0. So here everything we want here as a f only. So f it is here y dash square plus lambda into y of x. Now find out the derivative of f with respect to y dash and after differentiate with respect to x. Okay, now let's find out derivative of f with respect to y. So f it is here y dash square plus lambda into y of x. So with respect to y dash always 0, and lambda into y of x, lambda remains same, and derivative of y with respect to y, it is 1 only. So delta f by delta y, it is coming as 0 plus lambda times 1. Okay, that means total differentiation it is here lambda only. Okay, now we want the differentiation of with respect to y dash. Okay, f with respect to y dash. So with respect to y dash, y of x is getting 0 because both of are constant, and remaining term here y dash square. So differentiation of y dash square with respect to y dash, it comes only 2 into y dash plus lambda into y of x, it becomes 0. So its differentiation is 2 into y dash. Now our Euler equation, it says that we have to differentiate delta f by delta y dash with respect to d by dx. Okay, so we have to differentiate that one with respect to d by dx. Now differentiate it d to y dash into with respect to d by dx. Okay, so here differentiation of a 2y dash with respect to d by dx. Y dash, meaning of y dash, it is here y dash we can write as a dy by dx. Okay, y dash we write as a dy by dx. So d by dx under bracket 2 times dy by dx. Okay, so derivative of y and d by dx, it's double differentiation. Okay, so two constant common, so d square y by dx square. Okay, and d square y by dx square, we write it as the 2 into y double dash. Okay, so I got the second term, it is here d by dx of a delta f by delta y dash which is equal to 0. d by dx of delta f by delta y dash which is equal to 2y double dash. Okay, now put these values, this one and this one, in our Euler equation. So it gives, so here Euler equation represent delta f by delta y which is equal to lambda and minus d by dx of derivative of f with respect to y dash, which we have here 2y double dash. Okay, now solve it further for its solution. So by using Euler equation, we got the value here lambda minus 2y double dash which is equal to 0, then which we write 2y double dash which is equal to lambda and it shows that y double dash gives lambda by 2. Now we want the solution for y of x, which is given in our option. So reduce that double differentiation. Then we get it here. So we have to reduce that double differentiation. So we have to integrate that one to get our y of x. Okay. So integrate y double dash of x dx, which is equal to integration of lambda by 2 dx. So integrate y double dash of x, that means y dash of x. That means y dash of x, that one differentiation get cancelled with the integration, remaining here y dash of x, which is equal to lambda by 2, which is a constant, remains same. Differentiation of a integration of a dx, it remains x plus c. Okay, so again integrate once again, then we land on our y of x. Okay, so integration of y dash of x, which is equal to integration of a lambda by 2 x plus c. Okay, now proceed further. Y dash of integration with cancel with differentiation, so left over it is here y of x, lambda by 2, it remains same. Integration of x will be x square by 2 plus integration of constant with constant and x. Okay, plus c2. Okay, so we consider it as the c1. Now we found the value of y of x, it is here. So by using our given initial condition, find out the value for c1 and c2. So in initial condition which we have in our example, y of 0 which is equal to 0 and y of 1 which is equal to 1. So substitute y of 0 which is equal to 0 in our equation. That means y of 0, substitute in the place of x is a 0 everywhere. So lambda by 2 multiply by 0 square by 2 plus c1 into 0 plus c2. So this one totally 0, this one also 0. So c2 and y of 0 which is here 0. That means we got the value for c2 which is a 0. Now substitute c2 which is in our example. Okay, again y of 1 which is equal to 1. Okay, y of 1 which is equal to 1 in our y of x. So y of 1 which is equal to lambda by 2 into 1 by 2 bracket square plus c1 into 1 plus c2, we have 0. So y of 1 which is equal to 1 here. So lambda by 4 plus c1. Then after solving this step, we get the value for c1 which is a 1 minus lambda by 4. Now next we want the value for c1 and c2. So we found here the value for c2. Now let's work for the c1. For finding the value for c1, we have to use second initial condition y of 1 which is equal to 1 in our y of x. Okay, so y of x, it is here lambda by 2 into x square by 2 plus c1x plus c2. So already c2 is 0. Now let's work for c1. So y of 1 which is equal to 1, which gives y of 1 which is equal to lambda by 2, x replaced by 1, which divided by 2 plus c1 into 1 plus c2. I substitute here c2 as a 0. Now calculate the value for c1. I found the c1 which is equal to 1 minus lambda by 2, 1 minus lambda by 4. Now substitute value for c1 and c2 in our y of x. So y of x which gives lambda by 4 x square plus 1 minus lambda by 4 x plus c2 remain 0. Okay, now solve it further. We get the value for lambda. Our next job is here to find out the value for lambda. So using second integral which is given in our example, by using that second integral we get the value for lambda. Now substitute the value of y of x in our second integral. So second integral, it is here 0 to 1 y of x dx, which is a 0. Now substitute that y of x here in our second integral and then we get the value for lambda. So I substitute y of x, it is here integral 0 to 1 y of x dx, which is 0. So the value for y of x, which is a lambda by 4 x square c1x plus c2 dx. Integrate it further. So lambda by 4 remains same, which is constant. Integration of x square, which is x cube by 3. 3 multiplied by 4, it denominator it's become 12. Plus c1x integration of x which remain x square by 2 plus c2 constant with respect to integration of x, it is coming here x. Okay, so and apply the limit 0 to 1. Okay, after applying the limit we get the value here for the lambda is minus 6. Lambda is here minus 6, 1 minus lambda by 4. Now solve that lambda further, we get the values for lambda. So after solving integral we got the value for lambda which is here minus 6 into 1 minus lambda by 4. Okay, after calculation of these lambdas we get the value for lambda. So we got the value for lambda, c1 and c2. So substitute these values in our main y of x. So substitute these values here. Lambda which is a 12, C1 and C2. Okay. So lambda which is a 12 x square by 4 plus C1 which is here 1 minus lambda by 4 plus C2 it's getting 0. Okay. So this is the value for y of x. Solve it further. So 4 3s are 12. That means it remains 3x square plus 1 minus lambda by 4. Okay. So here we want the value for lambda also. Lambda it is remain, we found it here 12. Okay. So lambda is here 12. Okay. So 3x square plus 1, 4 3s are 12 minus 3. So 3x square minus 2, which is the value for y of x and which given in option number. So x, it was remaining to here. So I added x here, c1x, that's c1x plus c1x, and after calculation we got the value for y of x, which is 3x square minus 2 times x. So which is given in our option number A. Thank you everyone. So this is the complete solution which you can refer for your understanding. Okay.